Today we're going to move on to something called regressions. What I'm going to ask you to write down next to this is kind of like a definition, is a mathematical relationship between two variables is desired for predictive purposes. For predictive purposes. Okay? That essentially means that in order for you to make a statement that's trying to predict what's going to happen, you have to have two variables, something that they're influencing one another. And then I also want you to write, in the real world, the relationship between two variables is not always perfect. It's not always going to be exactly what you want. However, you're going to write, so we look for the, this is probably going to sound familiar, best curve that can fit the data. That can fit the data. Okay, so you actually did this back in Algebra 1. You guys did it more so with just lines. You did the line of best fit, where, for example, if you had, let's say this was your graph. You don't have to write this, but let's just say that this was your graph, and you had all these points here. Then the line, really, the line of best fit looked something like this. Okay, that's what you did back in Algebra 1. What you're going to be doing today is kind of like the same thing, but you're not only going to be talking about linear functions. You can also talk about exponential functions, right? Exponential looks like this. You're mainly going to, in Algebra 2, you mainly see exponential functions, but you can also see sinusoidal functions, which that's the periodic going up and down, right? Sinusoidal being sine or cosine. We'll practice with some more of those later on in the week. But anyway, in order for you to find the curve that best represents the regression, you need your calculator. So you're going to press Stat, Edit. You're going to fill into L1 and L2, List 1 and List 2. In order for you to clear it, you just go up to the top and highlight L1 or L2, whichever one you're trying to clear, and press Clear. Do not press Delete. Press Clear and then go down, and then it'll let you fill in new information. So Stat, Edit, fill in List 1, fill in List 2. The reason why you have 2 now instead of just 1 is because we're talking about a regression, which needs 2 variables. And then you're going to press Stat Calc, and you're going to choose your type of regression curve. So if it's asking you for an exponential, you're going to choose exponential. If it's asking you for linear, you're going to choose linear, so on and so forth. Again, I'm going to show you an exponential one. Your homework will also have linear, but those two you guys should be fine with, okay? So if we look at this first example, the population of Fire Island, New York has been recorded for the given years since 2005. The table below offers this data. So in the year 2006, there were 502 people. In the year 2008, there were 541. In 2011, there were 618, so on and so forth, okay? The first question, determine a best fit exponential equation. So this is important. Exponential equation, where x represents the number of years since 2005. This is important too. And y represents the population size. So x is years and y is population size. So x is your years, y is population size. You have to be careful though, because x represents the number of years since 2005. So when you go to type this into List 1, when you're talking about the year 2006, 2006 is 1 year since 2005. So you're going to type in 1, and then you're going to go down. Now we have 2008 is 3 years since. And then you keep going across. 2011 will have been 6 years, and then 8 years, 9 years, and 12 years. So the years are what's going into List 1. The population is what's going into List 2. Okay? Population you can keep like normal. So you type all this in, stat, edit, fill in list 1, the x's, and list 2, the y's, the population. Then you go to stat, calc, and you're going to choose exponential regression. I think it just says EXP if I remember correctly. So you're going to just scroll down until you see EXP regression. And then it's going to come up. You're going to just keep pressing enter until it says calculated at the bottom. And then it's going to give you a screen. It should have 5 lines on it because your diagnostics should be on. If you only have 3 lines, then you have to go back and turn your diagnostics on. And you can do that in the catalog. So what you are going to do for work, because this question on your readings exam would be worth 2 points. 1 point for the answer, 1 point for the work behind it, or something that we can use to kind of back you up. So I know this says round all decimals to the nearest thousand. You are going to write everything that you see on your calculator screen, and then you're going to take that and write an equation based on that. Okay, the calculator is not just giving you, I mean, essentially it is, but it's not plugging everything in for you. That's what you have to do on your own. So I'm going to pause my screen. I'm going to just write down everything I see on my calculator screen. Make sure what I write down matches what's on your screen and on your paper. Okay, so this is everything that you should have on your paper now. So again, it gives you the formula for an exponential equation, and it uses a and b, and it has a equals this. So that's what you would plug in for a. B equals that. That's what you would plug in for b. And the reason for r squared and r, that's called your correlation. I'm going to write it on the side. Your correlation coefficient. The closer that number is to 1, right? You want it to be as close as possible to 1. The more accurate your curve is, the better your curve represents the data. Okay, it's usually going to be 0.9 something, 0.8 something. You want it to be very close to 1. So I'm not done yet, though, because I have to write the equation, and I have to round all the decimals that I'm plugging into the nearest thousand. So my variables, I was told to use x and y, so I have to use the x and y. So I have y equals a is 461.65, round to the nearest thousand, 3, so I keep the 2. Times b is 1.0558, makes it a 6 to round, raised to the x power. So this is my answer. That's it. Okay? Second question, by what percent does your exponential model predict the population size is increasing per year? Justify your solution. So the reason why it says justify is just so that you don't just give an answer. By what percent? So if you remember, this is an exponential equation. It's talking about exponential growth because it's the numbers are going up. So whenever we're dealing with exponential growth, if you remember this formula, a equals p times 1 plus r raised to the t power, that's what that formula is up top. So this 1 plus r is where I find the rate. Now if you look at the 1 plus r, in our equation, the 1 plus r is the 1.056 number, right? It's in the same spot. So 1 plus r equals 1.056. You subtract the 1, the rate is 0.056, but the question is asking by what percent. So you move the decimal over twice, and you write 5.6%, okay? You're not going to use the b value that's in the question because it's saying to use your model, which is the rounded number, which is, again, the only difference is that's why it's 5.6 and not 5.583, so on and so forth. You're just going to use the equation from before. So that's your answer. And then the last one, determine during which year the population will increase to 2,000. So this was my equation, y equals 461.652 1.056 raised to the power of x. During which year? The year is represented by x. So that means I have to plug something in for y in order to solve for it. So we want the y value to reach 2,000 equals 461.652 times 1.056 raised to the power of x. Now, if you remember back from our entire exponential equation unit, our variable right now is up in the exponent, which means I have to use logs. So I divide both sides by 461.652. Divide by 461.652. On the left side, that's going to give me 4.3322267596 is equal to, this canceled out over here, 1.056 raised to the power of x. Once the base and the exponent are by themselves, you take the log of both sides. And the whole point of doing that is that on the right side, you can take your variable, which is like you can take your exponent. You can take your exponent and move it out to the front. So now we have x log 1.056. Divide the log away. This will cancel on the right, which will give me x is equal to. On the left side, when you do that, you get 26.9 blah blah blah. This though is asking you during which year. So it's during the 26th year after 2005. So your answer is going to be during, if you do 2005 plus 26, it would be during 2031. Don't worry too much though about finding like during which year things. Okay, you're more so going to be asked how many years it will take or what have you. Okay, if you have any questions, let me know. Have a good day.